Hi, my name is Robert Giamadio, and I'm in Physics Section 5. Today, we're going to have a bit of fun with magnets. At the same time, you will see how the magnets generate fields that not only affect the iron shavings, but also how they interact with each other. To start with, you need a few basic materials. First, a couple of magnets. Any magnet will work, but bar magnets are the ones that I used for this demonstration. You will also need something that's magnetic, like some metal shavings. Note, not all metal is magnetic. Let's begin with the basic magnetic field. I used two magnets that were attached to each other and then sprinkled the shavings over the top of a piece of paper. You can see where the shavings were attracted to the different polarities. Magnetic fields extend from the center of a bar magnet and move towards the poles. Depending on how strong the magnet is, depends on the magnetic fall-off. Next, let's look at how the magnetic fields interact with each other. You can see in this image that the field still extends from the center, but because the magnetic polarities are meeting between them, they also strain the shavings there. The closer the fields, the more compressed and the stronger the reaction between them. You can add as many magnets as you want and you will get similar results. The layout of the poles has a large impact on the way the magnetic fields interact with each other. In this example, you can see how I alternated the poles on the right and aligned the poles on the left. Can you see the different effect on the shavings? On the left, where the poles are matching, you can see the same kind of compressed reaction as with the previous image. The shavings are clumped together because both magnetic fields are pushing the shavings towards each other. On the right, where the magnetic fields are opposite, you see the opposite reaction. Since the poles are opposed, the fields are attracted to each other and create a continuous loop. The shavings therefore bridge the gap as they are being pulled in both directions. It's important to note the magnetic fields generated by magnets do not only extend horizontally, they also extend and bend vertically around the magnets. If you look closely, you can see the tips of the spires bending slightly towards each other. If you had enough shavings and a strong enough magnet, you could, conceivably, create a complete sphere out of nothing but iron shavings. On a side note, it's also important to note that as a magnet interacts with a metal, that metal retains a portion of that magnetic charge. It'll charge according to the pole that is being acted on it. So if you use the positive end, you get a magnetic piece of metal that is charged positively. If you take that positively charged metal and rub it against negatively charged shavings, you'll notice that this screw now is also a magnet in and of itself. So now that you've seen some examples of how magnets work and how their fields can affect the items that are caught inside them, can you think of any objects that you may use in your day-to-day life that are magnetic? How do you think those small fields affect the objects around them? Hopefully, with the information gained in this video, you can use that to explore these questions more completely.